In this video, we're going to talk about matrix scalar multiplication. Okay, and so what we mean by a scalar is just some real number that we're taking times a matrix, and we refer to real numbers when we multiply by them as scalars quite a bit of the time because what they're doing is they're scaling things up and down. Okay, so we think of scalar multiplication sort of like distribution of real numbers throughout a matrix. That is, when we say in general for a real number scalar c, and you notice I'm using a lowercase c. So lowercase c represents our scalar. Then we have lowercase c times uppercase a. So in other words, a real number times a matrix, okay? And what we get for an answer is some new matrix. This is a matrix, but what you'll notice here is basically when I said use distribution, we're saying let's take this real number c times all of the entries on the inside of the matrix aij. So essentially, we're going to use this to help us do two things. One, scalar multiply, and then the other thing is going to be actually carry out subtraction. So let's go ahead and take a look down here what we have. We have two matrices. We'll say matrix A here is this 3 by 3. I suppose I could write A 3 by 3. And both of these right here, we say 3 by 3. B is a 3 by 3 as well. And what I'm interested in doing is these operations down here. So when I write negative 3A, what I really mean is let's take negative 3 times the matrix A, which really is this 3, 0, negative 1, 5, 1, 1, 1, 7, negative 7, and 8. What we're really saying is that I would get this here. I would say I'd get, now carrying this out, I get negative 3 times 3, negative 3 times 0, negative 3 times negative 1. And then I would get negative 3 times 5, negative 3 times 1, negative 3 times 1. Down here I get negative 3 times 1. I would get negative 3 times negative 7, and then I would get negative 3 times 8. So you can see how writing all of this out really isn't worth our time. I just want everybody to know that it's really like distribution. So negative 3 times 3, right here we'd get negative 9. Negative 3 times 0, we would have just gotten 0, and negative 3 times a negative 1 is a 3. So we can triple everything in the matrix here. We get positive 15 here, and then make it their opposite. That is, we multiply by a negative. So it doesn't just triple everybody, but it kind of also flips their signs. So looking at this, we would say this is how you'd carry out scalar multiplication. This would be equal to, right here, this would be negative 3a's, essentially, okay? And it's still a 3 by 3, notice. So we say 2b, what would 2b look like? Now, doing this a little bit more mentally, we say 2 times all of this, 2b, is going to be equal to some new 3 by 3 where we just distributed. I would get 8, negative 6, 2 times negative 1 is negative 2, 2 times negative 7 is negative 14, 2 times 5 is 10, so I get 10 twice. 2 times 0 would be 0, 2 times 3 is 6, and 2 times 2 is 4. So this is our 2b matrix right here. What I want everybody to see is this. Right here, it says, let's take negative 3a and add it to 2b. So the interesting thing is, if I were to write this equation out, like I had been doing it and hadn't done anything up until now, here's how I would write it. I would say negative 3 times 3, 0, negative 1. We have 5, 1, 1, 1, negative 7, and 8, if I recall correctly. So we say this is our negative 3a, and we're going to add this to 2 times b. So add this to 2 times, now we had b out front here. We said b is 4, negative 3, 1, negative 7, 5, 5, 0, 3, and 2. So now the thing about this we'd have to do first is we'd go ahead and carry out our scalar multiplication. We're going to talk about properties of how you carry things out, or at least the order of operations when it comes to matrix operations, okay? But for right now, we would go ahead and scale both of these, and you can notice here that I've already actually scaled both of these already. We got negative 3a to begin with, and we got a positive 2b to begin with right here. So if we were to add both of these up now, we'd say I get some new 3 by 3, and I want everybody to know what I'm doing here. I'm taking this green matrix plus this green matrix right here. So we're going to get some new 3 by 3. We're going to add individual entries. So first row, first column, I get negative 9 plus a positive 8 is a negative 1. I get a 0 plus a negative 6 is a negative 6. 3 plus a negative 2 is a 1. Okay? So now 15 plus a negative 14 is a 1. Negative 3 plus a 10 is a 7. And negative 3 here plus this 10 is also a 7. Last but not least, we say 3 plus 0 is 3. 21 plus 6 is 27. And then negative 24 plus 4 is negative 20. And this would be easy to check by typing this all in on a calculator also. We could store this matrix A as A, store the matrix B as B, store those in, and then we could just type this phrase into the calculator. What it's going to do is it's going to pop this out for us here. So the last thing I want to mention is matrix subtraction. We say there's no such thing as matrix subtraction. So I want to make sure that everybody gets this note down here. But when you do subtraction, we're going to change to addition. Okay, and we're going to add the opposite. So essentially what we have to do is we have to transform this to, instead of a minus b, we're going to say a plus a negative 1 times b, or a plus a negative b. So essentially what we're going to do is if anybody ever said A minus B, what you do is you'd really just take matrix A and add it to the opposite of matrix B, which really is subtraction, but we have to represent it this way as a sum of a scalar multiple of this. Cheers.